Not all that long ago, I was searching Amazon for some smallish, medium-sized-ish displays, like color. But I wanted color. I'm looking for a color display. You know, maybe 2 inches. My idea was I wanted to create a remote control for an audio amplifier, but I wanted it to have a little, you know, a little touch, probably a color display. Touchscreen would have been good, but I was also thinking I might use the little capacitive button thing that the ESP32 has. So I was out on Amazon, I was looking around, and I found this, which, you know, 240 by 320 for, you know, it looked like it has a TFT. I think that means touch screen. Yeah, well, it says touch screen right here. And then I saw it say ESP32 right here. Or actually, I think what I did was I flipped the images. I was looking through the images of it, and I noticed that there was a room 32 on the back of this display, and look at this. There's also a TF SD card writer, and look at the price, $16. I mean, some of these ESP32 development boards are 10. You know, you can get them cheaper if you like buy 5 at a time. You can probably get them for like 8. It's pretty cheap. But still, though, most of them are about 10 bucks. So this is a display, a touch screen, and a card reader. Well, hey, turns out it's got even more than that. And I thought to myself, well, this just seems like a great bargain. But I started poking around, and there was no information. I couldn't find any information anywhere. I searched YouTube, I searched the general internet. I'm pretty sure I searched GitHub at the time. And I thought to myself, well, there's no information out there. Maybe if I'm the first one to figure it out and maybe make a YouTube video, maybe I'll get some views. So I ordered it. It's cheap. I might be able to use it for something. Probably can, right? So I got it in and I started trying to program it. And it was not easy. I did eventually find a GitHub resource that put me onto a little website out here called MaxBug. And while I'm scrolling through this, I'm seeing, okay, there's pretty good information. There's a little Chinese here, but most of it's in English. It lists out some stuff. This shows me the pins of the connectors, which is what pins are routed to the connectors and what pins they are on the connectors, which is great. Oh, and it came with a little pigtail, one little pigtail connector. I've got it connected here. And then it talks about the pins that are assigned to the LED. 3 pins are wasted on the LED on the back of the board, where nobody would ever see it if it was embedded in a project anyway, which is a shame. And then you see this, there's an external power connector, which I don't really know how that works. And then I saw this thing called audio out. I'm like, wait, what? Yeah, it's got an amplifier on it. It's got a little amplifier chip, and it's also got a photoresistor. And let's see, there's I think from here I've got a blown up version of this image over here. So yeah, look at this. There's this section right here with the 800Z, or is that a 2? 802A or 800ZA. This is a little 2-watt audio amplifier with its own little 2-pin connector down here, which is a standard that I couldn't get. It came with a little pigtail connectors to plug into these other 3 4-pin connectors. So temperature and humidity interface here, extended I/O here, and then down here there's a power supply base. Yeah, I don't know about all that, but the guy that did all this research on this MaxBug website took a good quality image of the board on the back side, and then he annotated it with the pins and how they're connected. So if you look here, like look at this little amplifier chip. If you look right here, it says IO26. Well, IO26 is one of the D to A converters in the ESP32. So that lets you know that, right, that the audio chip is driven by the ESP32 D to A converter. Which, you know, the D to A converter output wouldn't have enough power to drive much of anything. You know, you might be able to get it to drive some little earbuds or something, but, and it's only one channel, so it's not stereo. But still, I'm like, well, I should try to see if I can get that to work, right? So I kind of wanted to put together something that would get it all to work at one time. And that proved to be pretty challenging. Maybe more so because I'm maybe a little bit green. I don't know if I'd say green. I've done quite a bit with the ESP32s and the Arduino IDE. But I haven't done anything with some of this stuff, right? The D to A, I've probably never used that for anything. I've never used the SPI. I have one of my little projects uses SPI, but it was really dirt simple. All I ever do is read it. You know, this has like SPI used 3 different times, and including the card reader, the SD card reader, writer, right? So we got 2 different SPI buses. One of those buses has like 3 peripherals on it. And the other one has the SD card, and to try to get all that working at the same time is challenging. And to get the the little amplifier, what I wanted to do was to get it so that I could generate tones and change the frequencies of the tones, and to use one of the timers, the ESP32 timers, and an interrupt service routine to generate my tones. Well, that proved to be kind of challenging for me. I had done some stuff like that before, but I think my primary sort of idea was a little flawed, because what I wanted to do was, instead of changing the sine wave, I wanted to generate a nice smooth sine wave tone, right? Instead of sort of changing the period of the time of the sine wave in memory, I just wanted to create one sine wave in memory and then play it at the right speed by setting up the timer and the timer alarm, right? And then in the timer alarm, I would write a sample of the sine wave out to the audio, out the D to A converter. And then the next time it went off, I would just go to the next. And the next time it went off, I'd just go to the next. And then when I went through the sine wave buffer, I would loop it. Well, I wanted that thing to have a resolution of like 100 samples, which is, you know, pretty, for one transition of a sine wave, to have 100 samples is pretty good. Well, it turned out that, and I think this is what happened, when I wanted to play 100 samples and I started getting up around 2 kilohertz, the interrupt service routine wanted to get fired again by the timer before I could actually write the signal. Anyway, a little flawed in my thinking. I did get it to work, and then I found out that, and I want to show this, that the implementation of this little audio amplifier on this board is not all that great. But before I do that, let's talk about what we see over here. And to understand why we got this, or how we got here, this little UI here is based on another project that I'm working on, and maybe I'll put an outtake in right here, but it's a little grill thermometer that I created. This is a little project I've been working on for a while now. It's a grill thermometer. It's got two ESP32s involved. This one is an HTTP client. This one is an HTTP server. Connected to it is a Max 6635, I think it's called. This is like an amplifier for a thermocouple, a temperature sensor. Crank this up here. That's the wrong one. Whenever you see that UI there flicker, it is a little flick. It went out to the Wi-Fi and connected to that one and pulled the temperature. So you can see it moving around there. These little bands here are to let you know whether you've got a high or a low temp. Pretty simple. It is designed to have a battery in it so that this unit here is mobile. I wanted to make that one mobile too. These wires are hanging off because I'm struggling to come up with a good battery solution. Right now they're both just connected to this battery pack. But yeah, ooh, I'm getting a little hot. Let me turn that off. Which way does that go? Okay, there we go. So yeah, this will let me reset a timer. Now this is based on the WR. Hang on, I got it right here. Oh, the reason this one's over here is because I bricked it. Trying to get the battery stuff to work, I screwed up the serial interface between the USB to the ESP32, the thing that you use to program it. So that's what I mean. I bricked it. I can't program this one anymore. WT32 SC01. This is a pretty common, a pretty popular ESP32 module that's paired with a display, 3.5 inch, I can't remember the resolution. Pretty popular out there. So that's my little grill thermometer project that I've still haven't completed. I have been using it with the grill, right? This is all gnarled up where it's been it's got grease on it from the grill, so I've been using it and it works pretty good. I took that and I used the resistor, the photoresistor here, and this I converted the low to a volume. This is a volume control down here. I don't think I'm using the high for anything. But then I've also got it set up so that whatever you play on here, you can record, and it'll record it to the SD card, and you can play it back from the SD card. So a little demo of that, right? We've got this little thing here. And the more light that you remove, the higher the bar and the higher the tone. So if you remove light, it makes it go higher frequency. It's not really turning up the volume. The volume's the same all the time. And right now I've got it set. So if I go way up here, so you can tell that that little amplifier has some power. Now it's hooked up to a timpano full range speaker over here that I think it's rated at like 120 watts. So obviously I'm not trying to promote or trying to talk big about the power. I'm just saying it's got enough power to drive a speaker, you know. And normally an ESP32 D to A converter would not have that kind of power. So just as a little demo, you got, let me turn the volume down here. I got a lot of light in the room right now. Oh, I hit reset. Look, the reset board's on the back. All right. Now let me get things back. Okay, here we go. All right, now I'm going to record that. Now, this display on here it's in the number of the card, so it's like a 24 by 32, 240 by 320 pixels. It is color, which is really nice, but the touch screen on here is not capacitive; it's resistive. So if you're not used to that, I mean, it's not as accurate and it's not as, say, responsive as a capacitive touchscreen would be. But here I'm going to put it in record mode. So now everything that it receives right here, it's writing out to the the touch, dadgummit, the SD card. There's a little SD card plugged in right here. Oh. I hit reset again. All right, let's start over. Woo, that's loud. All right, here we go. There, call me Beethoven. All right, I'm going to put it in idle mode, and what that did was that closed the file. And now we'll play it back. I know it's goofy, but it's just a little project that sort of tries to use all the capabilities of this little card. Now, oh, there was another thing I wanted to show you guys. Let me pull up the oscilloscope. I think it's let's see, it should be showing. Yeah, okay. Now, I'm just going to kind of set this this thing over the thing so that I get a tone the whole time. And you can see what I've got on the scope there. You can actually see the steps of the digital signal that I'm sending out, the digital to analog converter. So this is actually, it's hooked up to the speaker. Now, if I'm going to vary the volume, and what I'm doing when I'm varying the volume is I'm actually changing the waveform, and that really high tone there at the bottom is a bug. It's when I send 0, it goes full blast. This is the lowest volume level, and you can tell by looking at it, right? There's only one thing in there's only one step in the signal. Now I can program up to 255 steps right, to the D to A. But the gain, so right about there is where it starts to clip. So if I go any higher than that, well, maybe it's here. Right about here it starts to clip. I'm going to disconnect the speaker so we don't have to listen to that ridiculous noise. So right about here it starts to clip. I'm only able to basically give from the D to A converter of the ESP to the input of the amplifier. I'm only basically able to give, it looks like about 10, an amplitude range of about 10, where I've got 255 that I could give it. The gain of this amplifier is just ridiculously too high. So here we are. I mean, we're clipping way, like, at beyond like an amplitude, a positive to negative amplitude in the digital numbers that I'm sending it. I'm only able to send it like from a 0 to a 12 decimal. That's the range I get. So the fidelity of it, well, I mean, it's bad anyway, right? Because it's the ESP32's D to A converter. But not only that, I can't use any of the dynamic range of the D to A converter because I can only send numbers that are like from 0 to 15 or something like that. Anything above that makes the amplifier clip. So, poorly implemented. The amplifier is poorly implemented. Maybe I can get in here. I mean, it just needs a resistor or a voltage divider between the D to A converter and the amplifier, or maybe the amplifier has some sort of resistor across it somewhere, you know, like op amps do, that control the gain, and the gain needs to be turned way back. So all in all, considering what all you're getting and, you know, the price, wow, what a great deal. I mean, seriously, because, I mean, an audio amplifier that could be used for tones, throw that out the window and don't even count it. A touch card, an SD card writer, they're basically dirt cheap. In fact, you don't even need hardware. You could just take the little SD card adapter that comes with your micro SD card, and you can solder wires to it and wire it to an ESP32, and you can read and write SD. So you don't really have to have one. Now, it's nice because it's on the board and it's mounted, and if you mount this board inside of say a 3D printed box and get it in there nice and solid, put a slit in the side, then you've got a place to plug your SD card in there without having to worry about mounting some little piece of plastic. Now, the screen, the resolution is not all that great, but it's plenty for a lot of things. I mean, this display is not bad. I mean, the flicker is probably just my inability to program it properly, and my inability to take full advantage of the Loven GFX library. That's the Loven GFX library is the only one I really got to work well. And the way I was able to get it to work was by using the resources that I found on this MacBug website. He's got a bunch of examples on here. I tried to get, I think I got one of them to work. I tried to get another one to work and couldn't. But I didn't really spend that much time on it. I kind of wanted to get this video out so that you know, people could start taking advantage of this little card. Let's see, what else? This website's pretty good. It lists out in a sort of graphic or a sort of table form here the pins. It goes into quite a bit of detail of what all is on here. Pretty nice, really. Shows it with a speaker. Shows the audio interface up here somewhere, and this is how I discovered how to use this little photo resistor. So, yeah, I think that for $17, you're getting a lot. Now the touchscreen, like I said, it's not capacitive, it's resistive. But if you were to, if you had that thing set up where you've got big buttons, I mean, this thing is pretty big. You could easily get 6 or 8 buttons on that screen, right? And they would be easy to hit with your finger, and you could go ahead and push it a little harder. Like, you don't just have to barely touch it. You have to kind of push it a little, You could easily create a remote control with this screen, I would think. And that's probably what I'll try to do with it, hopefully, maybe, if I ever get the time. So, what is the number? What is the number? It is the ESP32 2432 SO28 dev board. Buy one. It's pretty good.